so we're going to look at, ignore that. We're going to look at factoring polynomials, and I'm going to do it in sections because what I've done here is I've created a flip chart that has the different types of factorings that we need to know how to do. And so we're going to start with just basic information about factoring and greatest common factor, and then we'll do each little piece on its own lesson. So factoring a polynomial, all that means is that you're going to take something that looks like this. So you're going to start with something that looks like this, x squared plus 5x plus 6, and you're going to factor it, or you're going to rewrite it as a product so that it looks like this. So I just took a polynomial, a 3-term polynomial, a trinomial. Let me see if I can zoom in a little bit on that. Just so we can see a little better. There. So I'm going to take a 3-term polynomial and I'm going to factor it, or I'm going to rewrite it as a product. Just means I'm going to rewrite it as binomials that are being multiplied together. And that is the factored version of this polynomial. So this is what we want to have as our end product. This is what we want to finish with if this is what we start with and our directions are to factor. And so the way you can check it, all of the factoring, you can check your answers, make sure that they're correct, by multiplying or using your distributive property. Whatever you get for your result, for your answer, and if it matches what you started with, then you did it right. So I don't have a whole lot of room right there. I may just run it around the side. You can check by multiplying your result out if it is equivalent to the original, then it's right. Okay, so I can take this, I can multiply it back out and make sure it gives me this. X times x is x squared. 3x and 2x is going to give me 5x. 2 times 3 is 6. So I know that I've got my answer right. So we're going to start with just some basic factoring. We're going to start with greatest common factor. And so I know you already know what a greatest common factor is because this is really simple, basic algebra stuff. Greatest common factor is going to be the largest factor that every term has in common. That's why we call it a greatest common factor. So you're going to look for the common factors and you're going to, I say, quote, divide them out. You're going to take them out of that polynomial and write your result as a product of your GCF times whatever's left over, for lack of a better way to say it, just to keep it kind of simple for you. So this is what I'm talking about. My first example, and I'm only going to do a couple, so this is going to be fast. If I have 8a cubed plus 4a squared plus 12a, you're looking for the biggest factor. Factor is things that are being multiplied. The biggest number term, I should say, that will multiply by something else to give me these things. So I'm looking for my greatest common factor. The biggest thing that will go into 8, 4, and 12 is 4. So I can factor out a 4. And a cubed, a squared, and a, they only have one a in common. I can't take 3 a's out because there are only 2 here, there's only 1 here. So I can take out a 4a. And now here's where I say you're going to divide it out. If you want to look at it this way, 8a cubed divided by 4a is going to give me 2a squared. Or you can say, what times 4a will give me 8a cubed? And that would still be 2a squared. 4a squared divided by 4a is going to give me just a, and 12a divided by 4a is going to give me 3. And if you're not positive, you can check it and then multiply it back out. I don't know if this pen's going to show it. We'll see. If I do my distributive property real quick, and I multiply that back out, that's going to give me 8a cubed. Multiply, that's going to give me 4a squared. Multiply, that's going to give me 12a. And that matches what I started with, so I know I did my answer right. And I hope that shows up. I'm not sure if it will or not. Okay, one more example, and that's all I'm doing because greatest common factor is basic stuff for us. Alright, so example 2. I'm giving this example specifically because there is, that's x to the 5th and y squared plus 9x to the 4th y to the 2nd minus 6x cubed y squared. I picked this example specifically because my lead term here is negative, and so what you need to get in the habit of every time, all the time, when you're factoring, is if you can take out a greatest common factor, you need to factor the negative out with your greatest common factor, because when we get into some of the other types of factoring, that's going to be necessary to help you get the right answer. So I'm going to find my greatest common factor here. I know that it's got to be negative because my first term is negative. And then I've got a 12, 9, and 6. And if I factor a common factor out of 12, 9, and 6, the biggest thing that will go into all of those is a 3. X to the 5th, x to the 4th, and x cubed, so I can take out an x cubed. Y squared, y squared, y squared. They all have a y squared in common, so I can take out a y squared. Now, I'm going to put this here. If the lead coefficient is negative, as it was here, you're going to factor out the negative with your greatest common factor. Just get in the habit of doing that. Alright, so now I'm going to see what it's going to take inside here to multiply by the negative 3x cubed y squared to give me what I started with. So what times 3x cubed y squared will give me negative 12x to the 5th y squared? Notice if I took out a negative times a positive is going to give me back a negative. So your signs are going to change in here. So this is going to be a 4x squared, negative 3x squared negative 3x cubed y squared times negative 3x is going to give me a 9x to the 4th y squared. It's going to be positive. Negative 3x cubed y squared times, I got interrupted. I don't know where I was, but I think I was saying negative 3x cubed y squared times a positive 2 will give me negative 6x cubed y squared. And that's my answer. And you can check it. So here's the thing with the greatest common factor. For all of the factoring that we're going to be doing, before you do any of these other kind, whatever we're trying to do when we learn these other ones, I want you to always check for that greatest common factor first. Oh, goodness, I'm sorry. I can't even write today. This has been going on all day. Always check for that greatest common factor first. Every time, no matter what kind of factoring you know you're going to be doing, you check for that greatest common factor first.